Okay, this is kind of the same game as yesterday, but now it's a little more complicated. Okay, you see a logarithm, you want to make two tables. Okay, one for the exponent function because you're going to be making an inverse. That's y. Okay. These are going to have asymptotes. They're not going to be always 0 here today. And now let's get started. Okay, that's the setup. Now, first off, remember what I said, whatever in the parentheses goes out front. Now, if you have a plus or minus after the parentheses, right away you need to delete the minus 3 and bring that over here as a plus 3 to the y. Okay? So, same rules, 2 is your base, and y plus 3 is going to be the power. Okay? So you got base 2, caret, y plus 3. Now you're going to write it so the y replaces the x. Okay? So 2 caret x plus 3. Now the y is by itself. Okay, there's going to be some problems today where it's not by itself. Now, parenthesize the base and the exponent. The exponent is not just x, it's x plus 3. So you put that in parentheses and you are going to circle just the x. Okay, so when you make your function, your parent function, okay, that's a quick one. You're just going with 2 to the x power. We will have to translate the plus 3, transform it into a plus 3 here later. Okay. That's why it's always important to get the base and the power in the parentheses together. Okay. All right. So x 2 is bigger than 1, so that's a growth. I think they're all growths today. 2, 1, 0, -1, -2, -10 will determine that. Okay. So I'm just going to do 2 to the x power. So if I put a 2 in there, 2 caret 2, that's 4. And then this is 1/4. Base 2 to the 1, if I put a 1 there, we know that's just going to be 2, and then 1/2, and then 1. Now, take 2 caret -10. Don't try to mess with that plus 3. That's approximately 0. So y equals 0, but now you have an operation inside the function. Okay, it's a plus 3, that's inside, that's why you want to make a parentheses. So if I have to make a transformation from inside the function, that has the opposite effect to the x. Okay, so opposite to the x. We've seen that before. It's inside, you can write that if you want, or just remember it. So I go to all my x's and -3. Now, there are no operations outside of the power function. There's nothing in front, nothing behind. That's why you need to make the parentheses. Okay, so 2 minus 3 is -1, -2, -3, -4, -5, and then -13. Okay, the y stays. That's a stay because you have no operations other than the plus 3, but that's inside of the exponent. Okay. Okay, so the asymptote's staying at 0, but now we have to reverse our table. So instead of -1, 4, we're going to have 4, -1. Instead of -2, 2, we're going to have 2, -2. Instead of -3, 1, we're going to have 1, -3. And then we're going to have 1/2, -4. Okay, and we're going to have 1/4, -5. And then we're going to have 0, -13. Now 0 is still the asymptote, but now it's x that equals 0. Okay, oops, my bad. So x0 is right here. You just make that line, kind of trace over it. X equals 0. Then you start graphing, same as before. So 4, -1. 1, 2, 3, 4, down 1. 2, -2. 1, 1, 2, 3. Then all that's going to happen here with the 1/2, you're just going to get closer, just make closer and closer to the line. Okay. So there you have it. And it's your hook. Okay. Domain and range. Again, we have to invert the table. Now it's the range that's all. And I put x with 0. And all those x values are greater than 0 from your table, and also you can see they're going to the right, so it'd be greater than 0. Okay, next one. Y equals log base 3 of the quantity x plus 4. Okay, so again, xy, you want an asymptote. Xy, you'll want an asymptote. Okay, so the first thing I do is write what's in the quantity after the base, x plus 4. There's nothing after that, so I don't have to do what I did here and add or subtract. If there's something after, you got to move it over with the y as opposite inverse operation. But whatever's in that parentheses is what needs to be written down. Okay, here it was just x, so I just wrote x. Here it's x plus 4, so I write x plus 4. Now, 3 is the base, and y is the power. So base 3 caret y. Now, invert the expression, or the equation. So y plus 4 equals 3 caret x. Now, remember when you write an inverse, you want the y by itself. Well, this is easy to do. Okay, you would subtract 4 behind it. You can't subtract it from 3. 3 has to the power of x, that 4 is not, so I keep them separate. Now, it is still important, very important, for you to parenthesize the base and the exponent. Put the dang thing in parentheses. It's not hard. Minus 4 is not part of the exponent, though. That just came out. So the exponent's just x, okay? So what am I going to do? Well, it's a growth again. And then I go 2, 1, 0, negative 1, negative 2. So I go 3 caret 2, it's 9. And this would be 1/9. Oh, sorry, I forgot the asymptote. So you go negative 10. Put that down there, negative 10. Okay, 3 caret 1 is 3, so this would be 1/3. 3 caret 0 is 1. And then I take 3, raise it to the negative 10th power, and it's going to be 0. Okay. So y equals 0 is where the asymptote's at. Now, do you have any other thing inside the function? Basically, inside the function, you don't. It's just 3 to the x power. See, up here is 3 to the x plus 3 power, but the power is just x, so x is going to stay. Now, we do have an operation outside of the function, a minus 4. If it's outside, it has the same operation to the y. Okay, so minus 4 from all your y's, and that includes the 0, and it includes the asymptote. So that's 5. 3 minus 4 is negative 1. Negative 3. 1/3 minus 4, it's going to be negative 3 2/3. 1/9 minus 4. Going to be negative 3 8/9. And then 0 minus 4 will push that to negative 4, and that means the asymptote is shoved to negative 4. Okay. All right, now flip your table. So go 5, 2, negative 1, 1, negative 3, 0, negative 3 2/3, negative 1. Negative 3 8/9, negative 2, and then negative 4, negative 10. So negative 4 is still the asymptote, but now it's x, it's negative 4. Now your asymptote has shifted, it's transformed. So negative 1, negative 2, negative 3, negative 4. So that's where we need to set up our asymptote line at. Okay. Now it smooths that over. So 5, 2. So 1, 2, 3, 4, 5, 1, 2. I don't need to go by 5s or anything. Negative 1, 1. So I go negative 1, 1. Negative 3, 0. And then these other ones just get close to the line. Okay. That's what a logarithm function looks like. Okay. Domain, range. Okay. Range is all. The domain, you put x with its asymptote, negative 4, and it looks like all those are bigger than negative 4. Okay, So greater than, but not equal to. Okay, next one. Y equals log base 2 of quantity x minus 3. Then after the quantity we have a plus 2. Okay. xy, asymptote. And then over here is when I will flip it back. Okay. And then asymptote. Now you can't mess up on rewriting it. You set that quantity x minus 3 equals, okay? And then watch this cross, and then you have a plus 2 with that, okay? What did I tell you to do on the first problem? When after the quantity you have an operation, you get rid of the operation and go to the variable over here, and now you're good to go, okay? 2 is the base, y minus 2 is going to be our power. So 2 caret y minus 2. Now flip the x and the y. Y minus 3 equals 2 caret x minus 2. Now you got to get the y by itself. You'd add 3, but you can't. You have to add it behind the power expression. Now you're ready to roll. This is the base. X minus 2 is my exponent, okay, or my power. So you parenthesize the base and the power. And you want to just circle the x. If it's got something with it, okay, you're just focusing on the x when you fill out your table to start with. So 2 is bigger than 1, so that's a growth. And that's going to be 2, 1, 0, negative 1, negative 2. Negative 10 will help me discover my asymptote. So 2 caret 2, that's going to be 4. And this would be 1/4 then. 2 to the 1 is 2. You can kill 2 birds with 1 stone. That's 1. Because a negative power just reciprocates the product when you got a positive power. Okay, 2 negative 10, it's going to be 0. Always is. Okay, you can test it if you want. So y equals 0 is the asymptote, at least to start with. But we have some transformations we have to make. Inside the function, you have a minus 2. Okay, remember, this right there, inside the function, that's why you need to get the parentheses, does the opposite to the x, okay? So opposite of minus 2 is a plus 2. So because if I put, all right, I'll explain here after I get it. But then outside the function, you have a plus 3. That does the same to the y. Outside the function does the same effect to the y. So 2 plus 2 is going to be 4. And then 3, 2, 1, 0. Negative 10 plus 2 would be negative 8. Even though I'm not going to graph that, I'm still going to do it just for consistency. Okay, you have to adjust all your y's. That includes your asymptote value. Okay, so 4 plus 3 is 7. 5, 4, 3 and a half, 3 and 1/4. When you add a whole number to a fraction, it's just a whole number with the fraction. That's 3. That's 3. Now I'm going to explain why this works, because if I put a 4 in for x, what's 4 minus 2? It's 2. What's 2 to the second power? It's 4. And then adding 3 gives you 7. So if I input 4, I get 7. If I put 3 in, 3 minus 2 is 1. 2 to the 1 power is 2, plus 3 is 5. See, it works, okay? If I put a 2 in, 2 minus 2 is 0. Anything to the 0 power is 1. 1 plus 3 is 4, as you can see. Okay. Now, hard work's done. We just got to flip it. 7, 4, 5, 3, 4, 2, 3 and a half, 1, 3 and 1/4, 0. Okay. Asymptote I need 3, negative 8. 3 is still the asymptote, but now it's x equals, okay? All right, so x, we have to get to 7. I can make that by 1s easily, so I would go by 1s. I'm going to label where the 3's at, okay? So 3's here. There's your asymptote, okay? It's again, logarithms will have a vertical, okay? If it's just an exponent function to begin with and not log, okay, then it's horizontal, like we did a few days ago. Okay, so 7, 4, 3, 4, 5, 6, 7, 1, 2, 3, 4. 5, 3. 4, 2. And then basically you don't even need to make those other points, okay? You know what's going to happen. All they do is go against the asymptote line, okay? And there's function. So domain, range, x, and then range is all, okay? Because now, and then x and 3. Looks like all those numbers are bigger than 3, so greater than 3. So yeah, it's a little bit of work here. Okay, log needs a base. If you don't see it, use 10. Okay. All right, so you know what we need. We need two tables. One for the inverse function, and then one to switch it back to the original function. All right, so in the quantity after the base, you have x plus 4. Now, after the quantity, you have a minus 3. You got to get that out of there and put plus 3. Okay, so 10 will be our base, and the exponent's going to be y plus 3, the power. So base 10 caret y plus 3. Now write the inverse for it. So y plus 4 equals 10, y plus 3, and I got to get the y by itself. That's easy. You just minus 4 behind it. Okay? X. All right, now parenthesize the base and the exponent, and if the exponent has a number added or subtracted to the variable, you circle it. Okay? That's what you're going to do. Okay? It's because we want to just focus on the base 10 to the x. That's going to serve as our parent function. And that's, again, growth. 10 is obviously bigger than 1. Asymptote. Pretty sure by now you know that's going to be 0 to start with. So 10 to the second power. 10 caret 2 is 100. That's 1 100th. 10 to the first is 10. That's 1 over 10. 10 to the 0 is 1. Okay? And then the asymptote starts at 0, but it's not going to stay there. So inside the function, you got your 10 to the x, you also got a plus 3, so you need a minus 3 to all of your inputs, the opposite effect. Outside the function, you got a minus 4, so you have to minus 4 to all of your outputs, okay? So 2 minus 3 is going to be negative 1, 1 minus 3 is negative 2, negative 3, negative 4, negative 5, and then negative 13, okay? Then all these have to be subtracted by 4. That includes your asymptote. So that's going to be 96. That is going to be 6. Negative 3. 1/10 minus 4. It's going to be negative 3 and 9/10. So I'm just showing you for those of you who aren't good with fractions. When you take 1/10, it's going to be negative 3 and 99 100ths. Okay. Told you. 0 minus 4 is negative 4, and that takes the asymptote to negative 4. Now flip it. So it's going to be 96 to negative 1, 6 to negative 2. Because remember, if you have to invert it, then you'll need a table at the end where you flip the points. Negative 3, I guess that one really wouldn't matter. Negative 3 and 9/10 with negative 4. And then negative 3 and 99 over 100 to negative 5. And then we invert it. It's going to be negative 4, negative 13. And that takes our asymptote, x equals negative 4. Now, if you have one x value that's like way the heck out there, just don't graph it. That would be my advice to you. See, now I can just go by 1. So if there's one really super extreme point, you can just cross that out, and now I can just go by 1s on x and y. I have to get to negative 4, so 0, -1, -2, -3, -4. Make the vertical asymptote. Okay, and then start graphing. So 6, -2, 1, 2, 3, 4, 5, 6, 1, 2. Because that 96 just creates a big hassle for me. -3, -3. Okay, and then this other crap, you're just going to go that way, and then when you come in this way, you just get closer to the line. Okay, just sketch. It doesn't have to be perfect. Okay, so domain range. So x range is all. We put the -4 for the x, and all those points are bigger than -4. Just a 6 itself is bigger than -4, so greater than.